I'm going over the homework for 8.3. 568, numbers 3 to 7, 9, and 11, and 14. In this whole section, 8.3, we're looking at two things about rational functions: vertical asymptotes and x-intercepts. Vertical asymptotes are found by examining the denominator, and x-intercepts are found by examining the numerator. Let's take the first function for number 3. Y equals negative 10 over x squared minus 9. Now, any value of x that makes the denominator equal to 0 will make a vertical asymptote. So, solve the denominator for 0 to find vertical asymptotes, VAs. So we take x squared minus 9 equals 0. Now x squared minus 9 is the difference of two squares that factors to x minus 3. X plus 3 equals 0. And we get x equals plus minus 3. So we have two vertical asymptotes at plus 3 and at minus 3. So vertical asymptotes, y equals 3, x equals 3, and x equals negative 3. So let's look at these graphs. Which one of these has vertical asymptotes at 3 and negative 3? Well, A does not. A has no vertical asymptotes whatsoever. B has two vertical asymptotes, and they appear to come at, let's see, this is 4. So now let's look at this graph. Here's 2. This graph appears to be 3, and this appears to be 3. All right, now two vertical asymptotes, it's sort of hard to tell which one is 3. So let's consider x-intercepts for the first equation. An x-intercept, it's a value of x for which y equals 0. Now, if we look at this equation, there is no value of x that can make y equal to 0. The only way that the right side of the equation can equal 0 is if the numerator equals 0. Well, the numerator is negative 10, so it will never equal 0. So this function has two vertical asymptotes, but no x-intercepts. Okay, so when we're looking at this function and this function, we can see that this function here, C, has no x-intercepts. There's nowhere where the graph crosses the x-axis, whereas for B, you can see that B has an x-intercept. So there must be, for the function for B, there must be a variable in the numerator. All right, so equation for 3 has no x-intercepts and two vertical asymptotes. And this is really the whole lesson for 8.3. And we're going to be doing this over and over again. Let's look at 4. X squared minus 10 over x squared plus 3. All right. Now, first let's look for vertical asymptotes. X squared, we'll take the denominator and make it equal to 0. X squared plus 3 equals 0. Subtract x squared equals negative 3. Okay, x is going to equal plus minus the square root of negative 3. Now, that's a number, that's a complex number. It would be x equals plus minus I root 3. That's fine. But it's not a real number, and we can't graph it. We can't graph it on the xy coordinate system, which is only for real numbers. Okay, there is no place for complex numbers on this graph. So there are no vertical asymptotes. Now, if we look at the graphs, A has no vertical asymptotes. B and C both have vertical asymptotes. So the answer is that the graph that goes with equation 4 must be graph A. But let's look at this a little bit more. Okay, so there's no vertical asymptotes. What about x-intercepts? Well, we'll take the numerator and make it equal to 0. X squared minus 10 equals 0. Okay, x squared equals 10. X equals plus minus the square root of 10. Now if we look, square root of 10 is around 3. You can see that this graph has, so at minus root 10, y is 0. And at positive root 10, y is 0. Well, you can see there's an x-intercept here and here where the graph crosses the x-axis. And it's right around the square root of 10, right around 3. Okay? So, equation 4 has no vertical asymptotes, and it has 2 x-intercepts. At minus root 10 and at positive root 10, x equals. Alright, so equation A is definitely, graph A is definitely the graph that goes with equation 4. Now, we can already match up 5, but let's examine it for x-intercepts and vertical asymptotes. So 5, x cubed over x squared minus 4. Okay, vertical asymptotes. Well, we take x squared minus 4 equals 0. You can add 4 to both sides. X squared equals 4. X equals plus minus 2. All right. Now that's definitely, that looks like this equation here with, 2. Now, so there's 2 vertical asymptotes. X equals 2. X equals negative 2. So that looks like graph B. Now what about x-intercepts? Well, we have x cubed. Take the numerator, make it equal to 0. Well, the cube root of 0 is 0. X equals 0. So, when x is 0, y is 0. And you can see that B has an x-intercept at 0, 0. Right there. Okay? Alright. So, the graph that goes with equation 5 is definitely B. Okay. Now, we're going to do 6. So, let's take a look at 6. So, what's going on here? Now we have one graph, and we're going to choose a bunch of functions. Okay? And we're going to do everything the same way. Now, let's look at the graph, and let's talk about what it has and what it doesn't have. It has vertical asymptotes. It has 2 of them. Looks like it has a vertical asymptote at positive 2 and a vertical asymptote at negative 2. You can see it here on the picture. Okay? Now, does it have an x-intercept? That is there anywhere where the graph crosses the x-axis? Now, it approaches the x-axis here. The x-axis is an asymptote, but it never crosses the x-axis. Okay? So, we've got a couple of asymptotes. Now, this guy's got a couple of asymptotes, and this guy's got a couple of asymptotes. This guy has 1, 3x squared. 3x squared is going to have 1 asymptote. All right? Now, but which of these, this guy, 3x squared equals 0, so you're going to have an x-intercept at 0, 0. Here, x squared minus 4. You're going to have an x-intercept at negative 2 and positive 2. And x cubed, make that equal to 0. You'll have an x-intercept at 0, 0. There's only one graph which does not possibly have an x-intercept, and that's A. Because if you make 3 equal to 0, it doesn't equal 0. The numerator will never equal 0. A does not have an x-intercept. A has to be the equation that goes with the graph. Moving on to the next problem is number 7. Okay, identify the x-intercept and vertical asymptotes. Well, here, that's what we've been doing, so we're going to continue. And then we'll do 9, 11, and 14, and we'll be finished. Okay, so we got y equals 5 over x squared minus 1. Now, you don't have to graph this thing. You don't have to do anything other than identify the x-intercepts and the vertical asymptotes. So, first, vertical asymptotes, make the denominator equal to 0. X squared minus 1 equals 0. So you can just add 1 to both sides. X squared equals 1. X equals plus minus 1. All right? So, the vertical asymptotes, x equals 1, x equals negative 1. Those are our vertical asymptotes. Now, what about x-intercepts? The numerator is 5. 5 equals 0. Doesn't equal 0. It will never equal 0. 5 equals 5. No x-intercepts. In order to have an x-intercept, you need to have x in the numerator. No x in the numerator, you can't have an x-intercept. All right, so that was 7. Now we're going to do 9. So let's look at 9. Okay, f of x equals x squared plus 9 over x squared minus 2x minus 15. Okay, now we got to do a little bit of factoring. So we'll factor the denominator to look for vertical asymptotes. Now the denominator, what we're going to have x minus 5 times x plus 3, right? Okay, so the x equals 5 comma negative 3. So the vertical asymptotes are x equals 5, x equals negative 3. 2 vertical asymptotes. They are the roots of the denominator. Okay, now what about the numerator? X squared plus 9 equals 0. X squared equals negative 9. X squared, x equals plus minus I, the square root of 3. I times the square root of 3. Okay, well, that's a complex number, and so we don't use it. So no x-intercepts. Okay, next 11. Next to last problem here. Okay, y equals x cubed plus 27 over 3x squared plus x. All right. Now, let's take care of the denominator first and look for our vertical asymptotes. So we're going to have 3x times x plus 1. Okay? So we make 3x equals to 0, x equals to 0. So there's a vertical asymptote. And then we got all right, well, I got to start this one over again because I made a mistake. I only did it twice in class. X times 3x plus 1. Okay, so we got x equals 0. That's a vertical asymptote. And then we got 3x plus 1 equals 0. So x will equal negative 1/3. So these are the two vertical asymptotes. Now, what about x-intercepts? Well, we have to factor the numerator. X cubed plus 27. Okay? Now, there's a couple of things I want you to be aware of. Now, first of all, we can just solve it. X cubed make equal to 0. Then x cubed equals negative 27, so x has to equal negative 3. The cube root of negative 27 is negative 3. Okay, now you should just be aware, so we have an x-intercept at x equals negative 3. Now, this is a quadratic. What about the other solution? Well, a cubed plus b cubed, 27 is a cube, equals a plus b times a squared minus ab plus b squared. Okay, so x cubed plus 27 equals x, that's the cube root of x cubed, that's a, plus 3, cube root of 27, times x squared minus 3x plus 3 squared plus 9. Now, does this factor, or does it have, what kind of solutions does it have? X squared minus 3x plus 9. All right, well, it's a quadratic. It could have two roots. Maybe we got more x-intercepts. But maybe if you don't remember, this thing does not factor. In fact, if we do b squared minus 4ac, okay, b is negative 3, so that would be, and a is 1, b is negative 3. I'm using the quadratic formula, c equals 9. Okay, so b squared, 9 minus 4 times 1 times 9. Okay, that equals 9 minus 36. Okay, so that equals negative 27. All right, so b squared minus 4ac is negative. That means this quadratic has two complex solutions. Okay, b squared minus 4ac was positive. It'd have two real solutions. And if it was 0, it'd have one real solution. All right, so there is only one x-intercept at x equals negative 3. Moving on, we have the last problem, which is number 14. Let's see. Okay, multiple choice. What is the horizontal asymptote of the graph? Okay. Now, we got y equals 4x squared minus 21x plus 5 over x squared minus 12. Now, the only thing you need to remember, there's all kinds of really interesting things about asymptotes in this section, but we're not learning any of them, and we're not going to use any of them. Okay? So, but we are going to talk about what happens when you have two polynomials in a rational expression. Okay? Now, they're the same degree and the same variable. Now, the leading coefficient is x squared. Now, as x gets really big, everything else becomes trivial, unimportant. So, as x approaches positive or negative infinity, okay, this function is going to look like 4x squared over x squared. Okay, it's going to look like 4 billion squared over a billion squared, which means the x squareds cancel out, and so as x approaches positive negative infinity, y is going to approach 4, which is the ratio of the coefficients of the numerator over the denominator. This works if x in the numerator and x in the denominator have the same degree, same exponent. If they don't, then other things are going to happen, but we're not going to get into that right now. And that is all the homework for 8.3.